All right, so number 11 said you lift an object off the ground that has a mass of 40 kilograms. So M is equal to 40 kilograms. And up a distance, D, of 1.5 meters. How much work did you do to lift that object? So, what is the formula for work? Work is equal to F times D. What do I have? I have the distance. Do I have the force?
No.
But can I find the force?
Yeah.
How much force are you applying if you're pulling up off the ground? What's the formula for force? Force of gravity is equal to what? M times G. So F of G is equal to M times G. What's the mass?
40.
What's G? So now I have 400 newtons for your force. Okay? So now I can go ahead and figure out what my work is because all I have to do is plug it in. So work is equal to 400 newtons times distance, which is 1.5 meters, which is equal to what? 600 joules.
600.
Is that hard?
No.
Okay.
The best teacher ever.
Okay, so number 13 said if you were to drop the object from rest, how much kinetic energy would it have when it hits the ground? What did we say earlier about the work done and the kinetic energy? They're what?
You skip number 12.
Okay, let's do number 12. That was number 13. So let's work on number 12. Number 12 said, what is the potential energy of that object now that it is 1.5 meters above the ground? How do we figure out potential energy? Awesome. Mass times gravity times height. So what is the mass? 40 kilograms. What is gravity? 10. What is the height? The height is 1.5. So multiply 40 times 10 times 1.5. You're going to end up with 600 joules. Now that you saw that it's the same number, I want you to think of yesterday's example of the roller coaster. All the potential energy we had up on top transferred to complete kinetic energy down on the bottom, right? So if the number on top was to be 600, what's the number on the bottom? 600. Because it's a complete transfer of energy. So you start up with 600 and you transfer all of the 600 to movement, to kinetic energy. And that's why it's the same number. Now with that in mind, number 13 said, if you were to drop the object from rest, how much kinetic energy would it have when it hits the ground? So how much is going to hit the ground? The 600. So we're still looking at that same number. Okay? So that's for 13 as well. So the potential energy is lost. 600 is going to be lost, and all that 600 is going to plop onto the floor. Any questions? Okay, so for number 14, it says use the kinetic energy. So we just said that kinetic energy is going to equal 600 joules as well. It says use that kinetic energy to figure out how fast would it be going when it hits the ground. How fast? And when we say how fast, we're looking for velocity. So, which formula am I using? Exactly, 1/2 mass times v squared. So in this case, what are we doing? We're figuring out what v is. So my 600 is equal to 1/2 the mass, which is 40. And we are trying to figure out the velocity. Half 40 is 20. Divide both sides by 20. I'm going to go to... Okay, so again, kinetic energy is equal to 1/2 mv squared. 600 is equal to 1/2 40 times v squared. 1/2 40 is 20, so I'm going to do this slowly for you. So 20 v squared, divide both sides by 20, so v squared is equal to 600 over 20. 600 over 20 is going to be 30. So v squared is equal to 30. Square root of both sides, v is equal to 5.5 meters per second. Okay? We did square root to find the 5.5. We're good? All right. If this is working or not.